Hi, my name is Stephen Folsom, and welcome to the LD4 2020 Conference Workshop, a hands-on look at linked data. All materials and guidance for this workshop can be found in the GitHub repository link provided in this title slide. First, let's go over the workshop outline. There are 7 modules in total. With each module, there includes a video like the one you're watching right now. And in some modules, there will either be in video exercises or a paired exercise outside of the video. To begin with, we'll have an introduction to the workshop, which you're viewing right now, and an introduction to the RDF data model. In module 2, we'll go over Turtle, the terse RDF triple language. Module 3 will cover linked data in HTTP fundamentals. So how can we access linked data over the web? Following on that will be module 4, where we use a command line tool known as curl to access linked data with a known URI. Module 5 will be an introduction to Sparkle using the DBpedia Sparkle endpoint. Module 6 will do more Sparkle with Wikidata, and finally we'll close with some real-life examples I've used in my own work to do analysis for consuming and using existing linked data in applications in the Cornell library. So let's go over my background and our goals for this workshop. I hope we share these goals. First, I want to make clear that this workshop is based on my experience. It's certainly not exhaustive. For example, we won't be covering RDFA and microdata. I'm certainly not an expert in curl and Sparkle. I've used them in both tools in very limited ways, and you'll get a sense of that as we go through each module. Much of what I'll show in this workshop is self-taught. I expect that folks attending this workshop will have different experiences and approaches, and I hope you share those in the spaces where we can discuss the different exercises and communicate with other attendees for the workshop. I hope you leave the workshop with a reminder of what linked data is, more confidence with accessing and assessing linked data to consider how you could use it in your work, and a curiosity for more, along with connections with others who are attending the workshop. I want to give credit to the incomparable Christina Harlow for making me aware of these. In our discussion spaces, I'd really like us to adhere to the Recurse Center's social rules. So please, no feigning surprise, like, wow, I can't believe you didn't know that, or no, well, actually, please, let's try not to speak over each other and unnecessarily correct folks as they're participating in the workshop. Please, no backseat driving. So if you're going to comment on how to do something better or a different way, please fully engage with the participants. And lastly, no subtleisms. So let's make sure everybody feels comfortable and welcomed. So let's begin with the fundamentals of RDF. In RDF, everything is about the statement. The statement can include, or does include, a subject, predicate, and object. The subject is the thing being talked about. So in this case, my dog. And then there's a predicate, and this is an attribute or relationship to another thing. So something that we want to say about my dog or relate my dog to something else is that middle section of the statement. Predicates are sometimes called properties, so you'll see predicate in properties, the terms used interchangeably. And the object is the value of that attribute, or the thing being related. In practice, with the exception of blank nodes, and we'll get into that later on in the modules, and predicates are both identified using URIs. The object can be a URI for another thing or a string value. This may not be new information for you, but I thought it was worth starting with this reminder because the mechanics of accessing linked data over the web and constructing queries rely on these fundamentals. Another point worth mentioning is that RDF and linked data, or the data model in RDF and linked data is represented itself as RDF. So, and often published as linked data. These models are often referred to as ontologies. This means that the definitions of the data model, classes and properties, or the things that we're talking about and what we can say about them, can be accessed the same way that the data that we're using are accessed. In a sense, it's like if a data dictionary traveled with a spreadsheet to define its columns and rows while using standard internet protocols. In this example, the property FOF name is the subject of the triple statement. The statement is actually about the property itself. It's related to a string value using RDFS comment, and the value there, the string value, gives a human readable definition of the property. So a bit more, or a bit about RDF syntaxes. There are a handful of them that have been established over the years. RDF XML is an extension of XML to capture triples. Similarly, JSON LD is an extension to the JSON spec to capture RDF. And this serialization, we're starting to see more on the web, and is preferred by Google and other search engines. N triples is an older syntax. It's a little bit more verbose than the one that we'll focus on here today, but it's a subset of Turtle with where the URIs themselves are always spelled out. And lastly, the syntax that our workshop will focus on is Turtle, terse RDF triple language syntax. And the reason we're going to focus on Turtle is that it's a simple, compact serialization designed for legibility, and we'll see Turtle show up in our Sparkle modules. There are no exercises for this first module. In the next module, we'll do a deeper dive into the Turtle syntax.